fact, there's BBC bite size. So that's just your Nat 4 math, BBC bite size, okay. Where it says trigonometry, okay, that will give you everything, all the background to what I'm doing tonight, okay. So trigonometry in there, trigonometric skills, okay, and it will walk you through all your different parts of the triangle. So if you're not too confident in that, that's absolutely fine. Have a wee look through that, take a wee bit of time and get up to speed with the sort of content of that. We'll, over the next couple of weeks, so after next week's holiday, we'll look a wee bit further into things like sine, tan and cos and look at the graphs for that. Okay, so the trigonometric graphs and the shape of them and things like that. So we'll build up to that. So tonight, hopefully quite a nice class, introduce those rules again, get up to speed with a couple of questions yourselves. I'll introduce circles and how we can apply the rules to that, and then we'll call that right. It'll be lovely. Okay, superb. Right, let's get going. Okay, what we're going to focus on today is right angle triangles. Okay, now you've heard of all the different triangles, your isosceles, okay, your equilaterals and your obtuse. Okay, we'll start looking at them a wee bit more on Thursday, how we break them down and look at the different angles. Okay, what we sort of should be happy with all triangles is that angles add up to 180. Okay, so your three different angles in your triangle will always add up to 180. The right angle triangles we're going to focus on tonight. Okay, I've called right angle triangles because they've got a right angle in it. Okay, quite simply a 90 degrees angle in it. Okay, so being able to notice that in a question, okay, you're not always told it, so there's a few rules that we need to look at just to make sure that you're sort of aware of when right angles come up and what rules we're going to use then. Okay, so naming sides in a right angle triangle, we've got the hypotenuse. Okay, the hypotenuse, of which I've guessed the spelling. Okay, the hypotenuse is always the longest side. So the hypotenuse is always the longest side and it's always opposite the 90 degree angle. Okay, so if that's not obvious in the picture, if that's not very clear in the picture, okay, or it's sometimes quite close, the hypotenuse is always the longest side. Okay, so you've got one long side and two short sides. Okay, and the rule, hopefully you're familiar with or you've seen before. Okay, I use a squared equals b squared plus c squared. Okay, that's just your long side squared and the sum of the other two short sides. Short side 1 squared plus the short side 2 squared. Okay, that's all that means. Why I say that's all that means is because it's sometimes taught a different way. Okay, so whatever reason, and I swear I don't understand why, some get taught it c squared equals b squared plus, what is it, c squared equals a squared plus b squared. Okay, so they call the sides a different name. So some resources will have that. I think the dynamic notes has that. Okay, the notes pack in middle that I sometimes refer to, I think it does it that way. It means the same thing. They've just called the long side C, where I call it A. I much prefer using that for Pythagoras. A squared equals b squared plus c squared. I think that sounds daft, but some people have been taught it that way in school and just prefer using it because they're used to it. Okay, so I'm going to refer it to a squared as a long side. Okay. I hear a wee bit of crying in the background. It's me under my breath. Okay, so the hypotenuse is referred to as A. Okay, now what short side we call B and what short side we call C doesn't matter. Okay, Now those sides, the names of them do become important later on when we look at something called SOHCAHTOA, and that will make sense later on. Okay, so it becomes important what side we're naming in reference to a given angle. Okay, but at this stage, for a simple Pythagoras like this, hypotenuse is A, one of the short sides is B, doesn't matter what the other one's C. Okay, B squared and C squared are sort of interchangeable in that respect. Okay, very quickly, let's go through some of the very sort of basic questions you could get answered, stuff like that, questioned about, asked. My God, can't use my words today. Okay, and just finding a missing side. So that's X, that's 8, that's 6. Okay, that side X is obviously the hypotenuse. Okay, now again, they can refer to it as any letter. Okay, what I would write there is just x squared equals 8 squared plus 6 squared. Okay, so short side plus short side. Okay, and it's a square of those two sides. Just working through that, and you can sort of be as fast as slow. In the exam, I'd sort of just keep the technique that you just work through every line and you just do it methodically. Don't try and jump a line. Even when it looks like quite a simple equation, type it in the calculator quickly. Don't try and jump, just go through the methods. 64 plus 36, no problem. That equals 100. Then we're just taking that square across. Becomes a root. Root 100 equals 10. Okay, remember the units in this. So say that was in centimetres. Okay, just remember the units. Okay, just be careful with that one. They might give you a question where one of the other sides is missing. Okay. Okay, and they might call it X, whatever. You're aware that that's a right angle triangle. Okay. We're using the same equation, and then we're just rearranging it like we've sort of practiced a couple of weeks ago when we were doing the changing the subject. Okay, so it's still the hypotenuse, so it still follows the a squared, which is the hypotenuse, b squared plus c squared. Okay, so long squared equals short squared plus short squared. Okay, this time we've just missing a short side. Okay, so we see the right angle, we know we've got the hypotenuse. Okay, now at what point you want to rearrange this, it's up to yourself. I would just write it in this form. So one of the short sides is x squared plus 9 squared. Okay, again, you could rearrange it at this point. Okay, or you could work out what 15 squared is plus 9 squared, or I'll rearrange it for simplicity's sake. Okay, now I've moved this x sides, okay, when we've moved this over here. Well, that's what it looks like I've done. I've actually kept the x positive, so I've kept the x where it is, and moved the 9, and then just rotated that equation. Okay, so remember you can do that when you've got that equal sign. Okay, so keep the x squared positive, don't take that over and make it a negative effect, essentially. Okay. I'll just explain that in a slightly different way. What I could have done was 15 squared minus 9 squared on the left hand side equals x squared, keeping the x where it was. Okay, that's what I have done, but I've just put x squared on the left hand side because that's where I want x to be when we write our final result, or final answer. Okay, so I've just taken that and I've just rotated it. Okay. Okay, so we've got x squared on the left hand side, 15 squared minus 9 squared. Okay, oops. That'd be 144. Okay, so x squared equals 144. X, in that case, the root of 144, just taking that square to the other side. That side would be 12 in whatever the units are, centimetres, millimetres, metres, whatever it may be. Okay. So that's just missing the missing side part of it. Okay, so be comfortable with that. Pythagoras questions, you're often not finding the hypotenuse. Okay, you're often finding one in the middle, the missing sides. Okay, and then using that as part of the question. You'll see that later on, but just be comfortable with that sort of rearrangement. The only other two I sort of want you to be aware of in regards to sort of simple layouts is when you're asked to either prove it's a right angle. Okay, and when I say prove it's a right angle, you're given all three sides. Okay, and you're asked to prove that it's a right angle triangle. Okay, so what it's looking for you to do is taking your a squared equals b squared plus c squared, your long squared equals short squared plus short squared. Okay, take that equation, plug in the numbers and make sure that it works. Okay, so you're just proving that it works. So in this case, it'll be 5 squared equal to 3 squared plus 4 squared. Okay, 5 squared is 25, 3 squared is 9 plus 16. 25 equals 25, which is correct. Okay, so that proves that's a right angle. If that wasn't a right angle, then those numbers wouldn't add up to that. Okay, it wouldn't equal that. Okay, so I'll show you an example of that.
So would units be in there then? No, or is there a possibility?
Was that, sorry?
Is there a possibility it could be units in that?
Oh yeah, sorry. So that could be 25 centimeters equals 25 centimeters.
Thanks.
Yeah, absolutely. Okay, so same question. Okay, prove that that's, or is this a right angle, or prove the angle is not 90 degrees. Okay, so if you're given 17 and 8.9 and 50, okay, you would still put it in that formula. Okay, so that would be correct if it was 90 degrees. So we just go through it and put everything in. Okay, that's 289. Okay, and for it to work, the right hand side should be 289. The right hand side is actually, if you do put that in your calculator, it's 421. Oh. Okay, so that's not true. Okay. That wee thing I've done through the equal sign, that wee line I've put, that just means it does not equal. Okay, so if you see that wee line through the equals, it means it does not equal that. Okay, just that. Okay, so if you were to ask to prove whether it is a 90 degree you want that to ring true. Okay, that to add up correctly. If it's not 90 degrees, it will, something like that would happen. Okay, the left hand side will not equal the right hand side. Okay, so they're not overly common, but skills that you need. Okay, now I want to go through skills that we need for sort of Nat 5 that I'd expect, the type of questions that would come up in Nat 5. So we'll go through some simple examples. We'll go through some examples. We'll go through a couple of the questions in the booklet Okay, and then we'll move forward from there into these stories that are the most common. Okay, so these 5 examples, 1, 2, 3, 4, these 4 examples are relatively common, okay, but it's usually the wee story that we're after. Okay, so what you could get asked, okay, with right angle triangles is if you've got a graph, okay, if you've got a graph and you've got a straight line, okay, straight line graph, and you've got 2 points on that graph, okay, you could be asked a question which asks you something along the lines, the distance between that, okay, the distance between those 2 points. Okay, so I drew that triangle on a bit premature there, so I'll take that off. Okay, so you might get asked the distance between those 2 lines. Okay, so there's no obvious way to do that. Okay, that's right. Okay. The distance between the 2 points, however, we could create a right angle triangle from those 2 points and then work it out being the hypotenuse. Okay, so if we look at that then, we create a right angle triangle from that by taking a horizontal line from the bottom one and a vertical line from the top one. Okay, with those 2 points, we're going to be able to work out what the change in the x is, then the change in the y is. Okay, and that will give us the lengths of those. Okay, so the difference on x-axis is equal to 7 minus the 2, okay, 5. So we're going 5 units along the x-axis. Okay, so to get from that point there to your right angle that you've created, okay, you're moving 5 units. So you've gone from 2 on the x-axis to 7 on the x-axis. So that bottom length would be 5. Okay. You do the same for the y. So your difference in the y-axis okay, would equal to 10 minus 5. Or 5 as well? Yeah. Okay. So again, from that corner of the right angle to your point on the straight line, you've got the number 5. Okay, so you've moved up 5 units. Okay, so you've gone from 5 to 10. Okay, that's you essentially got the 2 sides of that right angle. Okay, and it's a case of just plugging it into your equation at that point, which we put in the format a squared equals b squared plus c squared, okay, which is long side and the 2 short side. The 2 short sides, the 5 squared plus 5 squared. Okay, so a squared being the hypotenuse. It's 25 plus 25 on the right hand side. A is equal to root 50, which would give you 7.07, and then whatever the units may be, that could come in units. Okay, If you're reading it off the graph, it probably wouldn't. Okay. So you're seeing how far along the x-axis you're going, you're seeing how far up the y-axis you're going, okay? Those changes, okay? So that could come up, and it's a nice way to sort of combine straight lines and another part of the unit, okay? Quite rare, but it could. So, ignore that. Ignore that. See where the questions start. Okay, so those type of questions on page 51, and we're in booklet 2 tonight. Okay, there's a couple of those questions on the bottom of page 51. Okay, now it'll just give you 2 points, it doesn't even give you the graph. Okay, but be aware that you might need to pull that off the graph. Okay, calculate the distance between 2 points. Try the one where they've got negative numbers in it. Okay, just to make sure you can sort of picture that in your head. Okay, so there's nothing different in regards to setup of it. Just need to understand or visualize where each of those points are. Okay, so even draw your own wee graph. Doesn't have to be to any sort of scale, but plot them. Okay, x and y, plot those 2 points, and then work out the distance you've changed in x and the distance you've changed in y. Okay. Second type of question is this type. Okay, where we've got a 3D shape. Now, this can throw people. Okay, because there's a lot of numbers and there's a lot of letters and a lot of sides and there's a lot of lines going on here. Okay, but essentially, just take it one step at a time and make sure you're picking up on the right letters. Okay, so
What page is that, Daniel, please?
that will be 52. So just question 4 on page 51, just a couple of those coordinate ones. Page 52 will give you a couple of the 3D shaped ones. Okay. Because, now I'm thinking about it, we usually do a topic called 3D vectors. Now remember, that's been cut out of this year's exam paper. Okay, so the SQA have cut that out, 3D vectors. I'd want to see how they would form a 3D shape question from that. Okay, so that might actually rule this type of question out. Probably won't. It's best to know it. Okay. But what we're looking at, sort of cuboid type shape. Okay, quite hard to draw out, so I won't draw it out. I'll just leave it. My God, sorry. At the center of the screen. Okay, got a long side. If we just look at that front face, in fact, I can annotate this. Okay, so that front face of that shape's just AD, and then you've got E and H as the corners. Okay, got the side shapes, which is DC, GH. Okay, you've got a couple of lengths there. Okay, so 5 is your vertical height of that cuboid. 4's, what would that be, width, breadth. Okay, 11 is that front face down there. Okay, that's your distance. Let's have a wee look at what it's asking. Calculate the length of the face AC. Okay, take a wee bit of time to find out what that shape's going to be. So that shape, A to C, is going to be your hypotenuse. Okay, that's your diagonal along the bottom face of that cuboid. Okay, you're given the bottom edge and you're given the side edge. Okay, so you've been given a right angled triangle. Okay, that bottom face. All that is just using Pythagoras to find out what AC is. Okay, so diagonal AC, the name will come from the letters. Okay, and that will be applied later on when we're looking at corners as well. So these letters will be an indication of what line you're looking at. So that line starts at A and ends at C. Okay, just putting that into an equation. Okay, so finding AC. Okay, I'll go back to my okay, finding AC. Okay, so just make sure you write down what question we're doing so you can refer back to it. Okay, I'm not going to try and draw out that shape, it'll just get a wee bit messy. Follow the same, a squared equals b squared plus c squared, so your long side equals short short. Okay, we know that AC is going to be the long side, so I'm going to put in AC squared there. Okay, AC is just the name of that line. Okay, and that just keeps me right. B squared, I'm going to put that front edge, and then C squared, I'm going to use that side edge. Okay, then it's just a case of working through that. 121 plus 16. What's that? 137. No, no. 121 plus 16. And C equals root of 137. And then the calculator. Okay, put that in your calculator. And then if that's in units, whatever that may be. Okay. The next part of the question, you need to use your answer in part A.
Which one's the root again? Sorry.
On your calculator.
Uh,
So there should be a wee root sign beside the x squared button in most calculators.
yeah,
Got it?
yeah. Thanks.
Okay. Some calculators will give the answer in surd form.
Yeah.
Okay, there should be a button on your calculator that allows you to change to decimal. Okay, so yeah, my calculator gives the answer of root 137 to be root 137. Okay, so just a case of pressing the decimal button. Okay, so we need to use that now. Okay, so if we look back at that question, we've worked out that length. Now the second part of it is working out AG. Okay, so the second part of that question.
Can I just ask a quick question about that?
Yep.
How would you know whether or not to use the 5? Is it because the 11 and the 4 are along that line A to C?
Yes.
Yeah, okay, that's fine. Okay.
So you're essentially you're turning that face into a 2D. Okay, so and this is what's hard about the 3D shape ones, it's trying to pick up exactly the face that they're talking about. Okay, so we know C is on that back corner. Okay, on the bottom of that shape. We know A is on the bottom of that shape as well. So the line joining those two letters is going to run right along that bottom face. So you need to take that bottom face and effectively just forget the rest of the noise. Okay, you're just removing the rest of it and you're taking all your methods is AD, DC, and then AC. You could even just draw that as a right angle triangle in your paper and just put those numbers on it. Okay.
Yeah, that's cool. Cheers.
Nice one. So we've found AC, so that runs along the bottom. Now we want to take into account the actual height of it. Okay, that actually becomes a side of our next right angle triangle because we're looking for that line AG. Okay, so those 3 dots that I've made, that's a slice right through that shape. Okay, slice right through that shape. Not find any rectangles. Okay, you can imagine it. So your opposing corners in that rectangle, A and G. Okay, G to C, that 5 centimeters. A to C, which is the bottom of that slice, is what we've just found out, which is 11.7. Okay, and then AG is going to be her hypotenuse. Okay, So find AG. Find AG. Okay, find AG, and again, it's just going to be in that a squared equals b squared plus c squared that I prefer. Okay, what's your hypotenuse? Your hypotenuse this time is your AG squared. Okay, if you want to put the rest of the lettering in as well, the bottom side is going to be your AC squared, and the other short side is going to be GC squared. Okay, so that makes sense to everyone? Happy with that? Okay, so GC is just the name of that line there. That's your 5. AC is what we've just found out. That's your bottom one. Okay, so just substituting all those numbers in. AC squared is your 11.7 squared. GC was 5. AG squared. Okay, AG squared. Just adding them together in your calculator. 11.7 squared. AG will be 161.89, and that would be the root of that. That'd be in whatever units it may be in. Okay, so centimetres for argument's sake. Okay, now that wasn't exactly 12.7. Okay, so just be aware that the question might ask for either significant numbers or decimal places. So just be comfortable with the difference between that. Okay, if it was 2 significant figures, your answer would be 12. If it was 2 decimal places, your answer would be 12.72. Blank. 0.72. Okay, so just be careful with the wording, significant figures and decimal places. It's an easy one to mix up. Okay. Right. Let's see what they've got in the booklet. Not much. Here's PR. Calculate the length of base PR. So what are they giving you? What are they giving you? 18. Okay, so quite similar. I'll just give you let's say until 7 o'clock, just to work that through on your own, just to sort of try and picture it. Okay, difficult one to draw out, but it's very similar to what we just did, so just work through that. Okay, so take until 7 o'clock and just make sure you can work through that. Okay. Okay, so this question, they're looking for the perimeter. Perimeter's the outside of that shape. Okay, now the question, an exam question, would throw a wee bit more words in there. Okay, it might make a wee bit more elaborate picture. Okay, that could be a swimming pool, it could be a building, it could be anything. Okay, but it's the same sort of thing, just taking out the data that you want. So that back of it's 20 long. It's not obviously to scale. That length down there is 1. That's 3.6. We'll ask you to find the full perimeter. So we're going to be missing this part here. Okay, so we're going to be missing from this corner to this corner, this length. Okay, so we want to find that missing one. Okay, what we want to do is create a right angled triangle. Okay, so you can see there that we can create a right angled triangle from the data we've been given, and that would find our missing side. Okay, so if we know from that top corner to the bottom one is 3.6, We also know that this corner to this corner is 1. Okay, it means the first side of a triangle that I'll put in green, not yellow. Okay, that's just going to be 3.6 minus our 1. Okay, so it's going to be 2.6. Okay, say meters or whatever. Okay, so that green side of that triangle is going to be 2.6 long. Okay, the long side, okay, it's just going to be the same length as the dimension we've been given up here. Okay, so that long side is just going to be 20. Okay, so we've got our right angle triangle, just a case of working through it, and we're working out to find the hypotenuse. Okay. (20 squared plus 2.6 squared). Putting that in a calculator. 406.76. And that could be centimeters, meters, whatever. Okay, now that's not the end of the question. The end of the question is in find the full length of the perimeter. So you'd have to add that 20.17. Okay, so perimeter total 20.17 plus your 3.6 plus your 20 plus your 1. And whatever that may be. Okay, meters. So. Okay, that would be your total perimeter. So they always add that little bit of extra layering. Okay, it's not simple Pythagoras, it's looking at a more bizarre question and try to pick that out. Okay. Last type I want to show you, in fact, 2 more types I want to show you. Okay, before we take a wee break. Okay, we'll be working with something called bearings. Okay, now we've not done bearings at all. Effectively, it's just your north, south, east, and west, working within that off a compass. Okay, now we'll do this in a wee bit more detail next week. Okay, but question that could come up, which would involve a right angle. Okay, 2 boats, A and B, 360 meters apart. Okay, we'll have a wee story. Boat A is 120 meters due east of a buoy. Okay. Boat B is due north. Okay, so 2 boats, A and B, are 360 meters apart. Boat A is 120 meters due east of a buoy. Boat B is due north of the same buoy. Okay, how far away from the buoy is boat B? Okay, so let's just draw that out. Think about it. So if we're looking at a compass, okay, we've obviously got north. Oh, north spelt with an M. Okay, got north at the top, east, south, west. Okay, if you get asked a question like this, you would be given the compass normally, but it's a good one to know. Okay, if you're not given a picture, Okay, you should be able to plot these sort of relative to each other. Okay, so we've got a buoy in the middle of the sea. Port A is 120 metres due east. Okay, so that distance 120 metres. Okay. Port B is due north. Okay, so straight up. We don't know the distance away from the buoy that is. Okay, so we don't know what that side is. We do know from boat A and boat B, 360 metres. Okay. Because that's north and that's east, that's giving us that 90 degrees. Okay, so all your points on your compass, okay, east to south, south to west, west to north, are split up by 90 degrees. Okay, so north to east is going to be 90 degrees, east to south, 90 degrees, south to west. So all the way around, we're going to have 360. So if you go north to south, it's going to be 180. North to west, going back on back 90. Okay, just be aware of that. So we've created a right angle triangle out of that. Okay, and now it's just a case of solving that right angle triangle. Okay, so it's they're just trying to throw you a wee bit, but it's just about pulling data out of that question. Okay, so a squared equals b squared plus c squared. Okay, we know that across from the right angle is going to be our longest side. Now that's going to be our hypotenuse. Okay, so this is just long squared equals short squared plus short squared. So long 360 squared. One of your short sides 120 squared, and then your missing side, we'll call it x. You can call it anything you want. Okay, it's going to be at x squared. Okay, and we're just going to rearrange that. Okay, put away from boy or something along those lines. Refer back to the question. Okay. Now, a check for that would be making sure that side isn't longer than the hypotenuse. Okay, that means you've rearranged it correctly or you've worked it out correctly. If you're getting something silly like 450 metres for that missing side, then that's your triangle, you know something's gone a wee bit awry. Okay, so just be aware of that and pick that up. Okay, so bearing questions, again, we'll come back to bearings probably on Thursday. Again, we'll look at bearings in a wee bit more depth, but in its basic form, if it's north and east, there's a 90 degree angle in there. Okay. Last ones. So, last type of question that I want to go over, which is straight Pythagoras. Okay, is when you get a wee story behind it. Okay, so there's a couple of bearing ones. Okay, so that's page 52. Page 52 has got a couple of bearing ones. Okay, if you want to try them out. There's a perimeter one. Okay, so question 17, page 53 has got a perimeter. Okay, if you want to try that out. Some area. Okay, what the hell am I looking for? Page 55. Okay, so question 10. Page 55 is the start of sort of applying the theorem of Pythagoras exam question type. Okay, exam level type. Okay, so I'll do 2 of these and then we'll take a wee break. So we'll be having a wee break about 7:30. Okay, so we'll do 2. So I'm going to do question 10. Okay, which is this one. And then 11, which is this one. Okay, so I'll do question 10 on page 58. Let's have a wee look at this. Why can't our slide there turn on? Okay. 2 boys, Scott and Callum, playing football. 1 point Callum C. Okay, so that position there. It's 25 metres due east of Scott. Okay, so in that case, when it's saying due east from Scott, okay, we're putting our compass around Scott and then we're going east from that. Okay, so he's directly in the horizontal with Scott. Okay, the ball is at position B. And then it gives you a nice wee diagram. 2 boys in relation to the ball are shown in the diagram. Okay, so you've got a 14 metre side, you've got a 25 metre side. Callum is 14 metres away from the ball, and angle SBC is 90 degrees. Right, let's go through what that's SBC. Okay, again, they've lettered each of the different corners of this triangle. Okay, so we've seen it with the cube and we've seen it with the pyramid. Okay, every single corner, so where sides meet, okay, they've assigned a letter to. Okay, so if we were looking for a length of a line, so say line SB is the line that we are missing, okay, that would just be known as line SB. If we're looking for an angle, okay, and if we're looking for that angle at B there, okay, if we're looking for that angle, we would name that angle with all 3 of these letters, okay, and B would be the middle letter. So if it's looking for an angle, and it gives you something like that, SBC, that middle letter is where the angle is. So that angle there that I've sort of circled, that's your 90 degrees. Okay, so line S into B goes into it, then B to C. So S to B, B to C. B is your middle letter, so B is where your angle's at. Okay. So we'll cover questions like that, so don't be thrown by it now, but that's all that means, okay? So it's just taking the letterings so we know what we're considering. Okay, so angle SBC, B is in 90 degrees, so we can draw that on. Okay, with that information, straight away, we know that the side opposite that is going to be our longest side. That's our hypotenuse. So the distance between Scott and Callum is 25 metres. That's our longest side. Callum to the ball, okay, B is the ball. Callum to the ball is 14 metres, and then we've got Scott to the ball, which is what we're looking for. Okay, from that, easy street, it's just Pythagoras. Okay, complicated nature of that question is just everything around it. All right, so where the points are and blah blah blah. Okay, but it's just extracting the data and putting it into the question. Okay, just working through that then, working out that missing angle. Okay, so I'll just take a note of that. What question are we on 10? So a squared equals b squared plus c squared. A squared is a hypotenuse. Okay, so you've got 25 squared, which was our hypotenuse. Okay, the opposite side to the right angle. 14 squared, which was Callum to the ball, and then C squared, which is Scott to the ball, and that's our missing side. Okay, so just working through, rearrange that to get C in its own. Oops. Okay, so 20.7 meters. Now it does ask for 1 decimal place. Okay, so give your answer correct to 1 decimal place. So that's what we've done, 20.7. The units are in meters. Okay, 25 meters, 14 meters. So SB is going to be in meters as well. So make sure you get the units and make sure you read how many decimal places or significant figures they're looking for. Okay, 1 decimal place, 20.7. Happy days. Okay. So nothing complicated once you fight through the gumph. Yeah. So anyone's still copying. Nice one. Okay, so side question 11 as well. This sometimes throws people. Okay. I've seen this a few times. Sandra, if I start cutting out the screen, just tell me. I don't know. So the stones on an engagement ring are arranged as shown in the diagram. Alright, the fact it's an engagement ring doesn't matter to the question. The diameter of each stone is 4 millimeters. Okay, so each one of these circles, diameter, which is the distance from one side to another, 4 millimeters. Okay, so A, B, C are the centers of three stones. Okay, so you have point, centers of 3 stones. Write down the lengths of AB and BC. So AB is your hypotenuse. BC is the distance from there to there. And calculate the points of AC. Okay, so part A of this question, why you're able to do it. Okay, as it goes from the centre of one circle to the centre of another circle, and it goes right through a diameter. Okay, so you can do that. BC, likewise, centre to centre. Okay. AC, we need to use Pythagoras for. Although, yeah, because there's a wee bit of overlap between those circles. So you need to use Pythagoras to work out what this AC is. It's not a straight case of one diameter plus another diameter. Okay, so AB is, so circles are touching each other, so it's diameter, centre of circle through a diameter to another centre. BC is centre to centre. Okay, so if you're calculating the length of AB, that's centre to an outside edge, which is 2 millimeters, outside edge to outside edge, which is 4 millimeters, and then outside edge to centre, which is 2 millimeters. So that length is going to be 8. Okay, so AB is going to be 8 millimeters. Okay. BC is one centre to another centre. So centre to the outside edge is 2 millimeters. Outside edge to centre is 2 millimeters. So that's 4 millimeters. Okay. So BC is 4 millimeters. Work out what AC is. Okay. So you can see these circles aren't quite outside edge to outside edge. So it's not going to be diameter to diameter, if that makes sense. So AC is not going to be a perfect number. So we're just drawing that out. They've given you where the right angle is. Okay, so we know that 8 is going to be our hypotenuse, 4 is going to be one of the short sides, and then AC once I can rub that out. AC is going to be our missing side. Okay, as simple as that. So it's not complicated, it's just working out what the question's asking you. Okay, so a squared equals b squared plus c squared. So a squared is your hypotenuse, 4 squared plus ac squared. Rearrange that. Put it in the calculator. Try not to press thumbs. 6.93. Okay, let's see if it asks you for anything. In fact, it's millimeters, isn't it? So it definitely asks for millimeters. Let's see if it asks anything else in the question. Okay, so it doesn't tell you to go to any specific significant figures or decimal points, so I would go 2 decimal points. Okay, 2 decimal points, leave it at that. So 6.93. Now, does that make sense? Yep, it's less than hypotenuse. Okay, it's more than BC, and we can see that on the diagram, it's going to be longer than BC. Okay, so everything makes sense to me. Move on. Okay, superb. Let's take a break. Okay. So, we've actually, believe it or not, covered quite a bit there. So, questions from page 51. Okay, so if you go to booklet 2, page 51, just have a wee scan through from there and see if you're comfortable with what the questions are asking you. Okay, so from page 51, coordinates, 3D shapes, got your bearings. Ignore this one, any of the chord questions, okay? That's what we're going to look at next. Okay, there's a perimeter, there's a wee question. That's, as questions go with relatively simple Pythagoras, that's quite an awkward one. Okay, question 18, so have a wee look at that. 19 is a shape, it asks you the volume. And then it's got the stories. So the exam type questions that would come up is your stories. Okay, we love a wee story. Okay, so there's nothing in there that's jumping out at me as something we shouldn't be able to do. Okay, so all the way to page 61, you should be able to do minus this chord question. Just ignore this chord question right now. Okay, and we'll do that next. Okay, so let's say we'll take a break until past. Okay, if in that time you want to open the booklet and have a wee look about, a wee scoot about, happy days. Oh, sorry, have a break until 8 o'clock is what I meant. Okay, so we'll take half an hour. So we'll take a break until 8 o'clock. Okay, we'll come back together at 8 o'clock. All right. Record this. Okay, so we're going to look at a couple of relationships you need to be able to pick up on in regards to triangles and circles and how they fit together. Okay, so it'll make sense once we start going through a couple of examples. Okay, so what happened there? Call must have dropped out. Give me 2 seconds. No, that's not a good sign. iPad said. Right, back in business. Okay, so relationship between triangle and circles. Okay, so we all know what a circle looks like. Sounds daft. Oh, that's not a circle, that's an oval. Okay, got a nice perfect circle. Couple of lines, intersecting lines that we need to be aware of and we need to be clear of. Okay, first two are the most obvious. Okay, diameter and radius, we know what they are. That's just a line that goes through the circle from one side to another. Okay.
Are you showing us that, Daniel? Yeah.
Good shout. One day I'll click diamonds. Okay. Thank you, Sandra. Okay. First line we need to be comfortable with, or we need to be aware of. Okay, is one we've been worked with lots. Okay, so diameter is a line that cuts the circle in half. Okay, it has to go through the center of the circle. Okay, so the definition of diameter, it goes through the center of the circle. Okay.
What's this called you're doing just now?
What's this called? So circles and chords, I believe. But it's to do with Pythagoras. It's sort of building up Pythagoras. So it's linked. I don't know if it's got an actual. It's going to be. Okay, so circles and chords. Okay, so that's the diameter. Diameter. Okay, half the diameter is the radius. Okay, from the center of the circle to the outside of the circle, it's your radius. Okay, comfortable with that. Next one, which will be new to us. Okay, well, that is a line, not a circle. Something called a chord. Okay, so a chord is a straight line. It cuts the circle from side to side. It doesn't go through the center. Okay, so you've got your center there, and then you've got a chord, which is a line just slicing that circle. Okay, now the chord could be anywhere in that circle or shown any position. Okay, so what I mean by that is what's shown there is a chord. Let's draw a couple more circles. Okay, that's a chord. Okay, the chord could be at the top of the circle, straight line, as long as it doesn't cut through the center. Okay, or it could be going sideways. Okay, so the chord could cut it like that. Okay, so it cuts the circle into a wee segment there. Okay, so a chord is a straight line, edge to edge, but does not cut through the center. Okay, so that's a chord. Edge to edge, but does not go through the center. Okay, so what can we do here? Okay, so we've got a chord. Big circle like that. Okay, we've got a chord. One side to the other. Okay, we know where our center of that circle is. Right there. Okay. The first rule you need to know is the distance from the center of that circle to the edge of that chord is your radius of your circle. Okay, now that makes sense. The center to the edge is the radius. Okay, so let's draw that on. The center to where the chord meets the edge of the circle is your radius. Okay, and that's either side. Okay, So both the blue line there and the red line is your radius. Okay. Now, with that, we can bring a line down from the centre to cut that chord. Okay, 90-degree angle. Why that's relevant to us right now is we can use the radius, the chord, and a line cutting that chord at perpendicular angle, okay, to create a right angle triangle. Okay, and it's that type of shape that they use quite a lot in questions, in exam questions. All they do is just change the picture of it, either change the direction of the chord or ask you different things, and it's about understanding what they're asking you is the most difficult part of it. So there's nothing in there, it's just creating a right angle triangle and then deciphering what they're trying to ask in the question. Okay, so let's use that, what we've got there, in a question. Okay. So, question, love a wee story in these questions. I'm just going to draw another circle. Love a wee story in these questions, so let's go through it. Okay, cross section. Cross section of an oil tanker is shown. Okay, so that circle with the chord across it is a cross section of the oil tanker. So that chord is actually showing the level of the oil inside the tanker. Okay, so if you imagine cutting right through an oil tanker, and that's shown. Okay, the surface of the oil is 250 centimeters. Okay, so what have they given us there? So they've given us the length of that chord. So they've given us from that point to that point. Okay, which is 250 centimeters. Okay. The diameter of the tanker is 300 centimeters. Find the depth of oil in the tanker. Okay, so a lot going on there. Okay, you've been given a picture, so you'll get shown a picture in the exam. It might not be marked up with much information. Okay, in the question, the surface of the oil is 250, so the length of that chord, so the line cutting across that is 250. The diameter of the tanker is 300 to find the depth of the oil. Okay, there's quite a lot going on. Let's think about what we can do with this information. What we want to do straight off the bat is create a right angle triangle. Okay, and then see where that takes us. So we draw a couple of lines on this. From centre of circle. Okay, know what I did there. Centre of circle to the end of that chord. That's your radius. Okay. Now the radius is half your diameter. Okay, so we can take that to one side. Radius would just be 300 divided by 2, which is 150 centimeters. Okay, so if we put that in there, we've got 150 centimeters. Okay, so that's the first bit of information we can put. Now, how I told you to create that right angle is we take a line from the centre of the circle and we cut the chord with a perpendicular. Okay, so we take a line from the centre, and we cut that chord in half. Okay, so where that's not quite perfect, but where that's cutting, that's halfway between, I'm sorry, that's right in the middle of the chord. That's what I'm trying to say there. Okay, so right in the middle of the chord. If you take a line and you cut that chord perpendicularly, you're cutting it in half. Okay, so that's done two things. That's created a right angle triangle. It's created a right angle triangle. But it's also cut that chord in half. Now we know that chord full length is 250. So by cutting that in half, we've created half that length, which is 125. Okay, so that line there is 125. Okay, so that allows us to do something. That allows us to find this unknown edge, okay, which I'll call x. Okay, so in questions and exam questions, they sometimes mark that as h, or they sometimes, you'll see some, okay, they sometimes mark it with different letters. I'm just going to mark it with the x there. So x is the number I want to find out, or the side I want to find out. Okay, so if I work through just working with Pythagoras, a squared equals b squared plus c squared. A squared is my long side, so that's 150 squared. Okay, that's your hypotenuse. B squared's one of the short sides. Then
Sorry, Daniel, where did you get the 125 from?
125 is half of the chord length. So I've taken the surface of the oil, it's 250 centimeters.
Oh, right, okay, thank you, yeah.
So that's that point there to that point there. Okay, so that full length of that chord. So that chord is meant to be a visualization of that 250 centimeters of oil. Okay. Okay. So that 125, it's just that 250 halved. So if I'm wanting to find that height, that missing side, rearrange that. Which is 6,875. Okay, so 82.92 centimeters. Now, let's go back to the question and see what it's actually asking us. Okay, so these type of questions we'll always have to work out where the right angle triangle is, and then that missing length. Okay, but let's see what we've found out and then what the question's asking. The question's asking find the depth of the oil. Okay, so if that's an oil tanker, the chord being the top of the oil. Okay, from the top of the oil to the bottom of the tanker is going to be our depth. Okay, that's going to be our full depth. So we've only worked out x, we've only worked out from the centre of that circle, okay, or the centre of the tanker to where the oil level is. Okay, so we've only worked out a wee part of it. What we want to work out is that full depth. So that's what we've just found out, plus from the centre to the bottom. All that line is just the radius. So it's our full depth, it's just a radius, okay, plus that side of the triangle that we've just found out. Okay. So our depth is just equal to 82.92 plus the radius. Okay, and we worked the radius out before. Okay, we worked the radius out to be 150. Okay, so 82.92 plus 150. Putting that in our calculator will give us 232.92 centimeters. Okay, so let's think about that and let's compare it to what we're seeing on the drawing. Okay, so it's looking for the depth. Depth is a chord above the center of the circle. Okay, so the depth that we are finding has to be more than 150 deep. Okay, we know it can't be more than 300, so it's a number less than 300. Again, that makes sense, 232. So we know it's somewhere in between the center and the outside of that tanker. Okay, so everything's making sense there in regards to that answer. Okay, when we look at that diagram. Okay. Let's look at another example. Okay, so that's quite a typical wee story, typical wee exam question. Let's look at it from our perspective. So if we start with a circle again. Okay. Example 2. Draw a chord. Draw it down the bottom this time. Okay. Indicate on our circle where the center is. And then the question will have more to it, but it will give you the information of this height. Okay, so that's 8 centimeters. Okay, so from the chord to the top of the circle, it says 8 centimeters. And could give you the radius. Okay. Radius 6 centimeters. Okay. So that's the entirety of the information that you get given in that question. So I'm not going to give you a story this time, just so we don't have time. Okay. Okay, so I'll cut out the story this time, but there'll be a nice story behind that, a pipe of water or whatever it may be. Okay, so we've got a radius of 6 centimeters, and we've got a distance from the chord to the top of that circle of 8 centimeters. Okay, what they're wanting you to find out is the length of the chord. Okay, so it's wanting you to find out the distance from that outside edge there to that outside edge there. Okay, now they might letter that A and B, and they might say find the length of AB, okay, or something along those lines. So they might add a wee bit more information in there. But essentially find the length of that chord. Okay, so if that's all we've got in the diagram, first step that we want to take is draw a line from the centre of that circle to cut the chord perpendicularly, like such. Okay, so that's just, in this case, it's just coming straight down and it's cutting that, okay? And if it's cutting that chord at 90 degrees, then it's cutting that in half. Okay, so we've done two things there. Okay, created that right angle triangle. Okay, we've also cut that chord into two equal halves. Okay, so we call that side X. Okay, X is going to be half the length of the total chord. Okay, and we'll call that side H. Okay, just H for height. Okay, now what information do we have there that will allow us to find either H or X, and then it allows us to find an unknown? Okay, in this case we've got that height from the chord to the top of the circle. Okay, now we know the radius is 6 centimeters, so we know from centre of the circle to the top of the circle is 6 centimeters. Okay, So that's 6 centimetres to the top to the centre. From the centre to the chord must be 2 centimetres. Okay, so H from the centre to the chord is going to be the 8 minus 6. It's just going to be 2 centimetres. Okay, so we found one of those unknowns. That allows us just to do Pythagoras to work out what x is. So we've got a squared equals b squared plus c squared. Okay, where a is 6 centimetres squared. B squared can be h, which is 2 squared, and then plus x squared. Okay. Done this quite a few times now, so 36 minus 4 is 32. Okay. Remember, that's only half the distance. Okay. So the total length of chord is equal to 5.66 times 2, okay, which is 11.32 centimetres. Okay, so let's just go up to the diagram and just have a wee look at what we've worked out. Okay, if anyone's still copying that, give me a shout. Okay, so it's the question's asking the distance between that point there and that point there. Okay, so that full length. What we've established is x. X we know is half the chord length. Okay, so 2x is going to be the full chord length. Okay, so 11.32 centimetres is that length of that chord. Okay. We're going to go through 2 more examples. Okay. And then leave you to call it a night, but I'll show you where the questions are for this. Have a wee practice and then we can talk about it and we'll go forward from that on Thursday. Okay, so example 3. Okay, circle, centre's there. Okay, where's the chord wanting to be? Let's put the chord at the side, like so. Okay, the chord length is 18 centimetres. Okay, so from outside edge to outside edge, 18 centimetres. Okay. Radius equals 12 centimetres. Okay. And we are looking for h. Okay. So we're looking from the left hand side of the circle to where the chord is. Okay, so very similar to what we've just done in the previous example, just another way of looking at it. Okay, so let's put all these different pieces of information into our diagram. We've got our radius. The radius is from our centre circle to the end of the chord. Now we could have done the other way as well, would have been absolutely fine. Okay, so that's our radius. So we know the radius is 12 centimetres. So that's going to be our 12. Okay, now that's going to be our hypotenuse eventually, but let's draw in our other side. So from the centre of the circle to the outside edge, we cut through perpendicularly. Okay, and we create a right angle triangle by cutting that chord in half. Okay, so we've created this length here from that point to that point, which is exactly half of the chord length. Now we know the chord is 18 centimeters total, so half of that length, okay, it's going to be 18 divided by 2, and it's going to be 9. So now we've got a right angle triangle, we've got a missing side, let's work it out. Okay, we'll call that missing side x, because that's what we've been doing. Okay, hypotenuse is 12, one of the short sides is 9, the other short side is x. Rearrange that. X is equal to 7.94 centimeters. Okay, so same process we've done all now. So nothing changed there, we've just put it in a different format. Okay, that's not the finished part, that's not us finished. We want to work out h. Similar to what we did last time, we're just adding it to the radius. So that x, we're just adding to the radius. So the rest of that distance from the centre to the outside edge, okay, it's just a radius. Okay, so h is equal to our radius, which was 12, plus our 7.94, 19.94. Okay, remember in units. Okay, remember units. Remember, ask for decimal places. 2 decimal places would be 19.94. 2 significant figures. 2 significant figures would be 20, because you'd have to round it up. Okay, so remember we'd have to round up. Okay, 20 centimeters to sig. Comment back the night like to add. Okay, I'll do one more example. Let's see if I can draw this out. Okay. And then I'll show you some of the questions and I'll leave you to have a go at them. And then I'll pick up from this point on Thursday. Okay. They sometimes like to have circles. Let's see if I can do this actually. Which overlap. Okay. Like so. Okay. Now that's how we look. Shape, shadow, switch. Try to take away the fill. Okay, so we've got 2 circles that overlap. Okay, and they'll give you this length. Draw a straight line out of this. Okay. I'll give you that length, and you might name that. Okay, and they'll give you where the centres of those circles are. Okay, and they'll give you some letters. PQ R S. Okay. Radius of circle P, 15 centimeters. Okay, so the big circle on the left hand side, radius of 15 centimeters. The radius of circle Q is equal to 13 centimeters, so it's a smaller circle. Okay. And RS, okay, length is 24. So line RS is 24 centimeters. Okay. What I would ask you to work out, okay, with that bit of information is determine distance from P to Q. Okay, so there's a lot going on there, but essentially what we're looking to do is create a right angle triangle on the right hand circle and a right angle triangle on the left hand circle. Okay, and then that will allow us to work out the missing sides, which we add together. Okay, and then we work out. So let's have a look at what I was talking about there. So we draw a line from P to Q, straight line. That's going to cut line RS in half, but it's also going to cut it and create right angles. Okay, now we've got radius, both radiuses, and we know the radius is from the center circle to the chord. So P to R, the radius. Okay, we also know the radius Q to R. Okay, what we've established there is two right angle triangles, one on the left hand side, one on the right hand side. I'll rub that out, do it down here. Okay, now lengths, we know P to R is a radius, and that's 15 centimeters. Q to R, we know is 13. And we know RS is 24. So because we've cut that RS line in half, okay, the height of that for both of our triangles is going to be 24 divided by 2, or 12. Okay, so now we've just got two sides missing. We've got P to the chord, which is that length there. And so, what do you want to call that? X. And call that V. Use any letter. Okay. So we've got enough information to find out what V is, and we've got enough information to find out what X is. Okay, so it's just a case of now putting that into two separate equations using both of those triangles. Okay, so triangle on the left. Okay, A squared equals B squared plus C squared. 15 is our hypotenuse, so that's our A squared. 12 is our height, so that's our short side, plus X squared, which is the other short side. We want to find the unknown, so rearrange. 15 squared plus 12 squared, 369. .21. Okay, and it's in centimeters. Okay, so that's the left hand side. We want to do the exact same for the right hand side. Get a bit more space. Okay, Pythagoras, a squared equals b squared plus c squared. A is our hypotenuse, which is 13 squared, equals b, which is our 12 squared, plus c, which is b squared. I'm going to sort it for our unknown. Oh, no, not 125, just 25. Sorry. Okay, so we've worked out what x is and we've worked out what v is. So the length p to q, okay, so line p q to x plus v. What have I done there? That time of night. Right, hold up. Sorry guys. This is wrong. I've done 15 squared plus 12 squared. So it's 15 squared minus 12 squared. So that is actually 81. That's root 81. And that will be 9 centimeters. Sorry guys. Okay, sorry, big mistake there. Okay, so we're getting 14 centimeters. So that line PQ is 14 centimeters. Okay, so quite an awkward looking shape. Not a lot of information given. Okay, using our rules of understanding where that chord sits and how a radius comes from the centre to the edge of the chord gives us the opportunity to work that out. Okay, so let's have a wee look at where you can find some questions. Okay, so from page 69, okay, so page 69 looks at the relationship between centre chords and perpendicular bisector. Okay, we've not done that last one yet. Okay, so I'll tell you the questions that we have that we can look at. So 1, 2, 3, and 4. Oh no, sorry, 4 you can. So 1 and 2 don't do, that's the different type, that's that perpendicular bisector. 3 and 4 is chords. 5 is a chord. Question 6 is a chord, and similar to what you'd see in a sort of exam type question. Okay. Page 71, ignore. Do that first thing on Thursday. And then from 72, you're into exam questions, exam type questions. Okay, so question 1 is a chord question. Question 2 is chords. 3, ignore. 4, ignore. 5, ignore. 6 is a chord. So 1, 2, 6. 11, 12. 1, 2, 6, 11, 12, and 15. 1, 2, 6, 11, 12, 15 are chord questions. The rest we've not looked at yet. Okay, so that's what we'll start Thursday with, looking at the rest. Okay, so 1, 2, 11, 12, 15, if you want to have a wee go at them. Okay, chord questions, and try and make sense of them. That question 6 is a good one to have a go at, try and understand. And that question 11 catches people out as well. Okay, so question 6 and question 11 especially, just have a wee go at them and try and make sense of that. Okay. Okay, so that is enough for tonight.